This is Jam Chem. Today we're going to do atoms and molecules. Atoms and molecules and atoms, molecules. Question number 1. What is an atomic orbital? Atomic orbitals are regions in space where the likelihood of finding an electron is very, very high. And by high, I mean 90 to 95%. Question number 2. What is a node? I thought you know that. A node is a 0 point where the likelihood of finding an electron is very, very small. Question number 3. What is the shape of an s orbital? An s orbital has the non-directional shape of a sphere. Question number 4. What is the characteristic shape of a p orbital? The characteristic shape of a p orbital is a dumbbell, and it looks something like this. I tried, okay? The nucleus is right here. Question number 5. Describe the orientation of 2p orbitals. There are 3 2p orbitals, and each one of these orbitals lie at a 90-degree angle to one another. Question number 6. What purpose does this orientation serve? The reason they lie at 90-degree angles to one another is because that allows for maximum distance between those 3p orbitals, and it also minimizes the repulsion of the electrons held in those 3 orbitals. Question number 7. Name one characteristic of electrons. Electrons have something called spin, and this can either be clockwise or anti-clockwise. Question number 8. What does this spin cause? The spin on electrons causes a small magnetic field called a magnetic moment. Question number 9. How many electrons can be held in one orbital? A total number of 2 electrons with opposite spin. Explain why. So if 2 electrons have opposite spin, and by opposite spin I mean one going anti-clockwise and the other one going clockwise, they also have opposite magnetic moments. And in 2 electrons having opposite magnetic moments, the repulsion between those 2 electrons can be minimized to an extent that they can become paired in an orbital, but they must be of opposite magnetic moment. Question number 10. Explain the Aufbau principle. So the Aufbau principle states that when you go from hydrogen to atoms with higher atomic numbers, the orbitals become filled in such a way that the lowest level orbitals are filled first. So for example, if we have 1s2 and 2s2, the 1s orbitals will be filled first before the electrons begin to fill the 2s orbitals. Question number 11. What is Hund's rule? Hund's rule states that in the filling of atomic orbitals, pairing of electrons in degenerate orbitals, and when I say degenerate orbitals, I mean orbitals with the same energy level, at the same energy level. So for example, the 3 2p orbitals are all at the same energy level. So pairing of electrons in degenerate orbitals only occur when each of those degenerate orbitals contain a single electron, and then the electrons can begin pairing. A popular metaphor used to describe Hund's rule is like, for example, when you go on a bus, you first attempt to sit by yourself, and when you can't, only then do you force yourself to sit next to a stranger who you'd rather not sit next to. Question number 12. What is the radius of an atom? The radius of an atom is the distance between its nucleus and its outermost electrons, also called its valence electrons. 13. How is this measured? So the radius of an atom is measured by measuring the distance between the nucleus of 2 symmetrical covalently bonded atoms and dividing that number by 2. And this can be like a diatomic molecule of hydrogen or chlorine. 14. What is atomic radii measured in? Atomic radius can be measured in nanometers or angstroms. 1 nanometer equals 10 to the minus 9 meters, and 1 angstrom equals to 10 to the minus 10 meters. 15. What factors affect the attraction between the nucleus and the electron? Number 1 is the number of protons in the nucleus, and number 2 is the number of shells containing electrons. 16. Define electronegativity. Electronegativity is the measure of a nucleus's attraction to its outermost bonding electrons. 17. What is the Pauling scale? The Pauling scale is a numerical measure of electronegativity. So if you should happen to wonder what the electronegativity of a certain atom is, you can refer to the Pauling scale. 18. When do atoms form ionic bonds? Atoms form ionic bonds when the difference between their electronegativities is higher than 1.7. 19. Why does carbon almost never form ionic bonds? Carbon has an intermediate electronegativity of 2.5, and this is between the extremes of a high electronegativity and a low electronegativity. 20. What is the formula used to determine the formal charge of an atom in a compound? That would be the number of valence electrons minus half the number of bonding electrons minus the number of unshared electrons. And when I say 21, what is a polar covalent bond? A bond with an uneven distribution of electron density. 22. When is a polar covalent bond formed? In some covalently bonded molecules, one atom is more electronegative than the other atom, and this atom with a higher electronegativity draws the bonding electrons towards it, but not enough for it to break off as an ion, but enough for it to have the largest share of electron density in that molecule. 23. What else can affect the polarity of a bond? That would be the polarizability of the bond. And the polarizability of the bond is the ability of its electron cloud to become distorted in a way that induces polarity in that bond. 24. How is the distribution of electron density in a polar bond shown? Like this. This means that the electron density is moving away from whatever atom this is under, and this means that the electron density is moving towards whatever atom this is under. Question number 25. What is a bond length and what is a bond angle? The bond length is the distance between the nucleus of nucleuses. Well, how do you say it? Nuclei of two covalently bonded atoms. If there are more than two atoms in a molecule, they form angles, and the angles between the atoms is called the bond angle. It can be anything up to 180 degrees. Question number 20. How are three-dimensional structures illustrated? This line here means that that bond is on the plane of the paper, or the whiteboard in this case. This wedge here indicates a bond going out of the paper towards the viewer. So this bond here is coming at you like this. And this line here, I don't know what you call this. Is it like a dotted wedge? I think they call this. This indicates the bond going backwards towards the rear of the paper, away from the viewer. 27. What is heterolytic cleavage? In terms of bond dissociation, heterolytic cleavage occurs when one of the atoms leave with both bonding electrons. Heterolytic cleavage results in the formation of ions. 28. What is homolytic cleavage? Again, in terms of bond dissociation, homolytic cleavage is when each atom leaves with one bonding electron, and homolytic cleavage results in the formation of free radicals. 29. Define the following: empirical formula, molecular formula, and structural formula. So the empirical formula shows the different types of atoms in the molecule and their numerical ratio, whereas the molecular formula shows the amount of each type of atom in that molecule as opposed to just the ratio. Now, the structural formula shows the arrangement of these atoms in the molecule. Structural formula is probably the most useful. 29. What is a cyclic compound and how are they represented? A cyclic compound is a compound that contains one or more rings, and they're represented using polygon formulas, such as and 30. What are dipole-dipole interactions? So molecules attract and repel each other. These attractions and repulsions are known as dipole-dipole interactions. 31. What are London forces? London forces arise from dipoles induced in one non-polar molecule by another non-polar molecule. 32. What is another name for dipole-dipole interactions, and What can affect these forces? Another name for dipole-dipole interactions are van der Waals forces. And what affects van der Waals forces is the distance between molecules. 33. What is the van der Waals radii? The van der Waals radii is the distance between molecules in which attraction is greatest. Any closer would be repellent, and any further away the attraction would decrease. 34. Explain why continuous chain compounds have a higher boiling point than branched compounds. A continuous chain compound, unlike a branch compound, is able to arrange itself into zigzags to reach the van der Waals radii. And because of this, it requires more energy to overcome those attractions. Branch compounds are not able to do this. 35. What is a hydrogen bond? Hydrogen bond is one that forms when a partially positive hydrogen atom of one molecule is attracted to the unshared pair of electrons or the electronegative atom of another molecule. 36. Discuss the dissociation energy of a hydrogen bond. So the dissociation energy of a hydrogen bond is 5 to 10 kcal per mole. And in comparison to a covalent bond, that's very low. However, a hydrogen bond is one of the strongest dipole-dipole interactions. And the reason why is because a hydrogen atom is very small and it's able to get closer to that electronegative atom in another molecule or to that unshared pair of electrons in another molecule. And because it's able to get closer, the dipole-dipole interactions are stronger as compared to larger atoms. 37. List some effects of hydrogen bonding. So one of those things is an increase in solubility. A molecule that can form more hydrogen bonds is more likely to be more soluble than a molecule that can form less hydrogen bonds. Another one of those things is boiling point. So if you have two molecules with the same molecular weight, the one that can form more hydrogen bonds would have a higher boiling point. And the reason why is because more energy would be needed to overcome those hydrogen bonds. Another one of those things is the shape of large biological molecules, such as proteins, whose structure is basically determined by hydrogen bonds. Also, DNA contains hydrogen bonds. So hydrogen bonds are pretty important. 38. What is an acid? According to the Bronsted-Lowry theory, an acid is a substance that can donate a hydrogen ion to a base. The hydrogen ion is also known as a proton. 39. What is a base? According to the Bronsted-Lowry theory, a base is a substance that can accept a hydrogen ion from an acid. And a base would either be negatively charged or have an unshared pair of electrons in order to form a single bond with hydrogen. 40. What is an acid-base reaction? A hydrogen ion is transferred from an acid to a base. 41. What is the difference between a strong acid and a weak acid? A strong acid is an acid that is completely ionized in water, whereas a weak acid only has a small proportion of its molecules broken into ions in water. 42. What is the difference between a weak base and a strong base? A strong base has a higher affinity for hydrogen ions than a weak base does. So basically, a strong base more readily accepts protons than a weak base would. 43. What is a conjugate base? A conjugate base is a base that's formed as a result of an acid losing a hydrogen ion in an acid-base reaction. 44. What is a conjugate acid? A conjugate acid is the acid formed when a base receives a proton from an acid in an acid-base reaction. 45. Describe the characteristics of strong acids and their conjugate bases. The conjugate base of a strong acid will be a weak base. However, the conjugate base of a weak acid would be high to moderately strong. 46. What factors affect acidity? Number 1, the size of the atom bonded to the proton. Number 2, the electronegativity of the atom bonded to the proton. 47. What does it mean for a reaction to be under equilibrium control? In an equilibrium reaction, the more thermodynamically stable product or reactant will predominate in the equilibrium mixture. And because of that, the reaction is said to be under equilibrium control. 48. How does the size of the atom affect acid strength? The larger the atom connected to the proton, the more stronger that acid is. And the reason why is because the larger the atom, the more it's able to disperse the negative charge of that conjugate base of the acid. So the result would be a more stable conjugate base. 49. How does the electronegativity affect acid strength? A more electronegative atom will more readily accept a negative charge than a less electronegative atom. So an increase in the electronegativity of an atom attached to the proton in an acid will lead to that acid being a stronger acid. 50. According to the Lewis theory, define an acid and a base. So the Lewis theory is different to the Bronsted-Lowry theory of acids and base. According to the Lewis theory, an acid is a substance that can accept a pair of electrons, and a base is a substance that can donate a pair of electrons. 51. What is the difference between the two theories? The Bronsted-Lowry theory only considers a hydrogen ion to be an acid. However, in the Lewis theory, not only is a hydrogen ion considered to be an acid, but anhydrous metal salts are also considered to be acids, such as zinc trichloride, aluminium trichloride, and etc. 52. 53. What is an acidity constant? K subscript A. An equilibrium constant reflects how far a reaction proceeds towards completion. For the reaction of the ionization of an acid in water, this is called the acidity constant. 54. What is the equation for the acidity constant? Concentration of products in molar over the concentration of reactants in molar. 54. Discuss both the Ka values for different acids and the pKa values. Any acid with an acidity constant value of above 10 is considered to be a strong acid. Now, pKa is just the negative logarithm of the Ka value, and the smaller the pKa value, the stronger the acid. Question number 54. What is the Henderson-Hasselbalch equation? The Henderson-Hasselbalch equation is based on the theory that when the concentration of undissociated acid is equal to the concentration of dissociated acid, pH is equal to pKa at that point. Now, using this theory, you can form the Henderson-Hasselbalch equation, which is pH equals pKa plus the logarithm of the concentration of dissociated acid over the concentration of undissociated acid. 56. What is the basicity constant Kb? So when a weak base undergoes ionization in water, the result is a very small concentration, but a constant concentration of ions form at equilibrium. The basicity constant is the equilibrium constant for that reaction. Number 57. Discuss the pattern of Kb values and pKb values. So the higher the Kb value, the stronger the base. And just like with pKa values, pKb is just a negative logarithm of Kb value. And the lower the pKb value, the stronger the base. That was atoms and molecules summarized into 57 questions.